maybe Raymond, maybe get Raymond to introduce himself, or Edward, do you want to introduce him, or how do you want to do that?
I
Although
think
he
Raymond
needs no,
can introduce himself.
I was going to say,
I
he
don't
needs
know.
no
I'm
introduction.
sharing. Can we see it?
Yes, I can see it perfectly. Thank you.
Let's see. Oh, okay.
Looks
That's
beautiful.
fine. So, can I go ahead? Oh,
You can go ahead. Yes.
all right. The very quick.
I think it may be helpful, Raymond, if you turn off your video.
Warm.
And with.
Yeah, sorry, Raymond, we can't hear you at all. So turning off your video sometimes helps. But if the connection is not working, no problem. We can reset. Yeah. He got bounced off. We'll give him a minute. There, he's back on.
We talked about having the presentations sent to one of us, so we could run it, maybe.
There it is. Raymond, yeah. Raymond, I see you're back. If you turn off your video, the internet connection is usually a bit stronger.
Okay. So let me do that.
Mm-hmm. Yeah, and then share screen again. And it might be a bit better. I'm just going to mute everyone else, just so it's nice and clear. Good. Yeah, we can see the presentation, the PowerPoint.
Okay.
Yeah, and your connection sounds stronger. Thank you.
All right. That's fine. So today we are looking at troubleshooting and the repair of a radiant warmer. And we have a particular one, which is the Draeger resuscitator. That is what we have. So the examples that will be seen will be based on that particular radiant warmer. And as known already, my name is Raymond. I'm working with one municipal hospital as the clinical engineering manager over there. So for our topic today, when we say radiant warmers, what we are looking at is a device that produces a controlled heat to newborn babies. This is done purposely to prevent what we call hypothermia during delivery or postnatal care. Mostly in the hospitals, like our hospital here, we have it in our delivery ward, and also in our NICU. Now, the temperatures or the heat which are being produced by this device are supposed to be very stable to create the enabling environment for our neonates. And it is obvious because of its important function to know that any malfunction can endanger the neonatal safety. Thus, as engineers, when we timely do troubleshooting and restore them to function, it goes a long way to help. So if you look at the Draeger radiant warmer, which picture you see on my left, there are some main components that will be of interest to the engineer when it comes to maintenance or troubleshooting to assess what actually caused the malfunction. And one of the components that you'll be looking at is the heating element. Then we have the solid state relay. Then we have the power or the control board or the motherboard. We also have the skin and air temperature sensors. And on the face, there is a display which shows whatever parameters that are needed are being displayed. So you also have to look at the display and then the control panel. Now, in our case, there was a case that was reported, and the reported case was that the radiant warmer displays an error message, that is error 5. That is the report, and because of that, the nurses complain that they don't feel the heat coming out from the system, and also because of that, during maybe resuscitation, they are not able to use it, so they have to call in for us to go and do assessment and see what the problem is. And that is the error message being captured as seen on my left, the picture. So before attending to the problem, I took time, we looked at the service manual. Fortunately, we had it online. So we're able to see to get some guidelines as to what could have been the cause of the problem. And if you look at the error numbers, we have error 2, error 3, error 4, error 5. The error 5 gives us a clue that SSR1 failed. That is the solid state relay failed. And if it failed, there could be a problem of open circuit, or the heater itself had an open circuit, which ideally is supposed to be closed to provide continuity. So because of that, in our search for what the issues are, we went directly to check the relay and that of the heater, and we discovered the problem. So what is the root cause of this error? As the manual has suggested, that there's an open circuit, either the heating element itself or the solid state relay that closes to supply power to the heater. Now, in our thinking, these are some possible causes which we think that could have brought the issue of the open circuit. And the first one is the heater element. Either it is bent, or secondly, either there's a loose or a broken wiring connection, which is not permitting the circuit to close to enable power to flow through. Or, as the service manual has suggested, either the solid state relay had failed to close, and because of that, we are not getting any heating. And the last possible cause will be either the power issues or control PCB defects. If the board itself is defective, then you might have to consider replacing it. So, troubleshooting procedure. So we followed this procedure to be able to identify the exact cause of the problem. What did we do first? Visual inspection to check the power, the fuses, the connectors, and then heater cables, which because it have to do with power or circuit not closing, there could be a fuse which is blown. So we did a visual inspection and everything seems okay. We didn't have any issue. Then we did a continuity test. And then from standard, when you do a continuity test of the heater, the resistance, it should pass. And at the same time, the resistance that you will get for any heater that work with 230 volts should be between 70 to 100 ohms. So we did a continuity test of the heater, and the switch was verified. And also, so if we had followed all these procedures and the board or the heater was the issue or the relay, then it will require us to replace them. But there was one thing we had to take in consideration, that's our safety. In doing all this check, we had to put out the power to ensure that there is no power flowing through the machine. Then we went on to do our analysis. Now, when we did our findings, the visual inspection, there was no any external damage. The cables were fine. There was power flowing through. Then we did the continuity test, which of the heater, which there was no reading. So if you look at the multimeter, the wires are connected to the terminals of the heater, and you see it's reading 0L, meaning that there was no any resistance, neither was there any beeping sound. So we also, so from all these tests, we realized that the heater element had an open circuit, or possibly the filament or the element is bent. Now, in an ideal situation, the action taken, in an ideal situation, the best thing would have been for us to replace the defective heater elements. After replacing, we would have checked the wiring to make sure that everything is connected or all are secured, and then would have performed a warm-up or a temperature stability test to be sure that the machine is working before we return it to. But in our case, getting the new element was a challenge. So we have to open the heater element and remove, let me see, I'll come back. Okay, I didn't add a picture of what we did with this. I wanted to show a picture first. So we open up the heater elements, which locally here we normally say the bulb. It's I think 2015. We have been using this machine and it has worked for a while now, a long while now. So the filaments are all weak. So we rejoin them, and then we perform the continuity or the resistance check. If you check on the multimeter, you see 64 ohms. The 64 was the resistance that we had. And the possible reason for the drop, because we said that the normal range for radiant warmers ranges from 70 to 100 ohms, but this one is 64. During the repair process, several parts were broken, so we have to take a portion of it away and make do with the remaining portion, which still seems strong, and we join them together. After that, we reconnected it, we checked the wiring and the connectors, everything was secured, and we performed the warm-up temperature stability test, and it was working perfectly. So at the end of the service, The error, which was error 05, was cleared, and the equipment has since been returned to service after the checks. Now, this is what we did with regards to the radiant warmer, but in our normal or daily practices, our preventive maintenance that we always carry out on the machines are to inspect the heater and the wiring regularly. Because the heaters are normally inside, this one takes yearly when we are doing maybe thorough cleaning from within the casing of the heating element. Then we clean the reflective surfaces and then air vents. And then we also monthly will do function tests of the heater sensor, the sensors that are normally placed on the baby, that's the temperature sensors. Then there's always the need for us to do electrical safety and calibration check. But on our part, normally we will use the tester to check whether the casing, there's any leakage of power. If there is no anything of that sort, then we continue using it, because we don't have the complex device that will enable us to do proper electrical safety check. Now, out of this, what we have learned, or what I've learned in the process, was that the error codes which normally are put on the machines are very good, and they always guide the technical people like myself to be able to diagnose. But I must say that every error code that is found in the manual will still have to be verified. Will still have it verified. I was trying to get a scenario where there was a similar machine it's a very long time now, about 2-3 years ago, that the error code the machine was given, the interpretation was somehow different from what was happening to the machine. I couldn't actually remember and get the actual story, but I remember I ever had an encounter. It was totally different. Now, the solid state relay and the heater are mostly or frequently the failure point for us to consider when it comes to radiant warmers. The service manuals and the test tools are also very vital. And with this, I must appreciate Ghana Medical Health for their yearly support of tools. Without multimeters, without basic instruments, this work wouldn't have been able to carry out. So Ghana Medical Health, we are grateful. Then 40 units must be moved from the clinical use immediately and work on so that it can be returned to service at the appropriate time. Now, these are some of the safety precautions that we considered as we work on. You realize that I've been using the word we. During the repair process, we are two in the department, I and Mr. Isaac Kwenu. So we work together to restore the machines back to function. Mains should always be disconnected before opening it to prevent electrical shock. And we also have to allow components to cool before touching, especially the reflective part of the radiant warmer. Possibly, we are supposed to use insulated tools and PPEs. And the last point is that only qualified personnel should always be engaged in what? The maintenance. In concluding, effective troubleshooting of the Draeger radiant warmer requires understanding of error codes, the circuit function, and safety protocols. And it is good, as we all know, that regular preventive maintenance ensure reliability and neonatal safety. In preparing this presentation, these are some of the materials I use. The Draeger Resuscité, the service manual, then France Hospital Workshop equipment database also gave some ideas concerning the circuit and components function. Then this is a forum too I have joined where they normally will share ideas with regard to medical equipment maintenance, MedRate Technical Forum, then the standards for neonatal thermal devices. So thank you so much for your attention and listening. If there's any questions, comments, or contributions, you are welcome. Thank you.
Excellent presentation. Thank you, Raymond. I've opened up the chat. If anyone has any questions, they can put it in there. Or if any questions, you can unmute yourself and ask Raymond now. Thank you, Raymond. Excellent.
Thank you.
And if nobody has any questions, I don't know if Martin or John, if you have any comments or feedback in general for Edmund or this topic that you wanted to add on to. Martin, I see your hand is up.
No, I was just saying that was just excellent, Raymond. I was trying to type into the chat here, and really good suggestions on the end, including the references. So thanks for that. My only question is actually, how did you actually fix the heater, the quartz heater element? That's what I'm most keen on. I know you don't have a picture, but I'm wondering if you can, because that's the tricky part.
Okay, just give me a minute. Let me go back to the background of my computer and share a picture. I have some. Just a minute, I will be done.
Once you've found it, there's two other questions that are in the queue.
Okay, can you see this? This is the filament.
Yes.
So the idea is that once there is continuity and power is passing through, you should be able to get the filament heating. So any broken part is twisted together. This is an experience I had with washing machine heating system, because it was difficult getting the heater element, and we really needed the machine to work. So when we tried that, the idea came. So we tried that, it worked. And we applied that same principle with this one too, and it has also worked. We know that because the filament itself is weak, it might not last, which we are looking for. We are sourcing to see where we can get a new one and replace. But for now, I think it has worked for almost 2 months now without any issue. So that's just as simple as that. Just twist it together to get your continuity, and you fix it back, and it's fine.
Thank you, Raymond.
Actually, let me add, because if you look at this particular picture, you see that the the light has come on, but it is not uniform throughout the filament to the whole assembly. It's not uniform because the filaments are very weak and already has formed in a particular shape. You are not able to get a stretch in the filament straight to equally distribute the heat, what do you call it, across board. But however, when we did the testing with the temperature stability, it was fine. It was working well.
Thank you, Raymond. Ebenezer has a question, and then I'm not sure who is Galaxy Holly Stars inspirational, but that'll be the next. So Ebenezer, go ahead.
Yeah, can I go on?
Yes, please.
Yeah. All right. Thanks for the opportunity. I'm sorry, Raymond. I think this is a very clear and let me see, a massive presentation as well. But I want you to clarify something for me.
Okay.
The error code, which is the 05.
Yes.
In the manual, what exactly does it, let's say, signify?
Okay, this is the screenshot of the manual. If you look at 5, it will say SSR1 field. That is a solid state relay field. And in the bracket, open circuit or heater open circuit. So it gives two suggestions, either the solid state relay, because from the relay, when it activates and closes, then power will go to the what do you call it? The heating element. And to do assessment on the relay, it is easier for the heating element because you can simply check continuity or resistance of the system to be able. So when we just did that check, we realized that the heater was off, and we needed to work on that one specifically. Thank you.
Thank you, Raymond. Next, again, I'm not sure, but the phone, whoever is Galaxy Holly Stars inspirational, you can go ahead with your question.
Yeah. Thank you very much for giving me this opportunity. Please, my question is, assuming the radio warmer is giving a high temperature readings, what are the possible causes that may lead or that leads to abnormal temperature readings? Thank you.
Okay. All right. Thank you. So, let me not be specific here with the radiant warmer, but with all heating elements, there are always sensors that monitor the heating, and the accuracy of response is dependent on the sensitivity of the
We've lost your audio, Raymond.
Yeah, so I'll give you a typical example, but not with radiant warmer, which I have a similar experience. That is an incubator, a laboratory incubator for you. You realize that you set your temperatures to 37. At times, the thermometer will be reading at 39, sometimes 40, giving overheating. And people will be calling that their slices are being burned out. The first one you have to check is whether there is a dirt a residue on the sensors that actually monitor the heating. If there are, you clean, but as time also goes on, the sensitivity also deteriorates, which may need that you have to replace the sensor to get your accurate heat control. If not, you always have the issue of what? Overheating. Thank you. Maybe seniors are there if they could also add to the question that has been asked. Okay.
Thank you, Raymond. Are there any other questions or anything to add to that?
All right. I think my network didn't favor me along the line, but just a follow up on the same question that I asked. The error code showed what's the name, a problem with the solid state relay.
Yes.
But then in your after the investigation,
Yes.
it looks like you is a heating element issue that you were able to find, right?
Yeah.
I just want to get the whole thing well. Is that the case?
No, if you look at the error code, the system gave a clue that solid state relay failed. But if you look at the bracket, whatever message is there, it gives you some components that are attached to the solid state relay, which is the open circuit or the heater open circuit. And if you look at the connection, the diagram on the board, from the solid state relay, it comes to the heater. So either if the relay is malfunctioning or the heater itself is malfunctioning, the relay could be working all right, but it will still be giving the same error message. Though the manual specifically is mentioning the solid state relay, but what I understand is that normally you have to go beyond just what is mentioned. Look at the other attachments to that particular system being mentioned, and you'll be fine.
Okay, so my final destiny is this. I asked this question because of, I think, the advice you give at the end of your presentation.
Yeah.
I don't know whether I heard you. You said aside the error codes that the device display, we should try to go beyond that. I don't know. Did you say that?
Yes, I did. I'm trying to.
And then you said you had a similar experience. I don't know.
Yes, I was trying to remember the story very well, but my memory is failing me, so I think this happened somewhere either 2002 or 2001, and the error was pointing to the board, the PCB board, but upon further checks, we realized that it wasn't the PCB. It was something that was taking power from the PCB. So, but even when I was preparing the presentation, I was trying to put it inside, but I couldn't remember what exactly that equipment was. So I decided to leave it out. But error codes will always guide us. But maybe if the error code have just mentioned the solid state relay, when you go in, you may be tempted to just change the solid state relay, which might not be the problem. So if you look at the solid state relay, you have to look at the surrounding components that are connected to the solid state relay. Or if you have a way of testing it, the solid state, to confirm that indeed that was having the issue, then you can do that to confirm before you think about replacing. That is the advice I was giving. Thank you.
All right, very clear, very clear. Thank you.
Thank you both very much. This is really great. John Ziena, you have had your hand up next.
Yes,
Thank
I just want to contribute to the discussion that Raymond just finished with Ebenezer. Usually, the relay is connected, one side of the relay is connected to one side of the element, assuming that one side of the relay is connected to the live side until the current passes through and circulate. It should have to circulate and come back to the neutral connectivity before the relay will click. You get the point? So the relay probably got open because of the break in the element that actually disenabled the relay, and then it actually got opened. So you really, mostly, if you don't have a circuit completely running from the live connectivity to the neutral connectivity, that is what will happen. In this case, I think that's what happened, because there was a break in the element. I don't know whose side is connected to live or whose side is connected to neutral, but actually, that is what might have happened. One side of the relay, it could be the neutral, it could be the live side, but it has to come complete to come and complete the circuit, because it's the relay itself is a safety device.
Yeah.
Now, assuming that the relay coil got bent, it will stuck in. You get the point? When the relay, it will get stuck in there, and obviously, when you look at it closely, nobody will tell you. You will see that the relay coil is gone. But it's a good observation. The fact that the relay was still okay, but opened, it meant that one side of the element, like you rightly said, got broken. And that actually pointed to the opening of the relay. So when we are analyzing circuits, we should look at sometimes the way components are interconnected so that you can get it. For example, you talked about, you mentioned the incubator, isn't it? Oh, no, a lab incubator.
Yes, yes.
Yes, controlled by a thermostat. It's the same thing.
Yes.
The connectivities are the same. One side is connected to live, other side is connected to the neutral, until you have a complete circuitry coming in. The relay will not come on.
Yeah.
So it's excellent presentation. I hope Ebenezer is a bit clearer to you. Okay,
Yeah,
thank you very much.
sure.
Yeah. Okay. Thank you.
Thank you very much, Mr. John Ziena. There's one more question. I see, yep, again, Galaxy Holly Star's Inspirational's phone. You can go ahead and ask your question. Thank you.
Thank you again. My question is, like, during his presentation, he made mention of the resistors of a personal radio that ranges from 70 to 100 ohms. So assuming you open a different brand, whereby the resistance or the resistors that they use is different from what he is indicating. So is there need for you to change the resistor, or you have to leave it that way? Because I don't know of the trigger this radio woman, but we have others which is coupled with so many motor functions. Like we have some radio women that are being connected to phototherapy as at the same time sensing. So other than that, we're trying to analyze the radio woman. So we were installing it, but later on we have to open and just check the motherboard and all those stuff to see whether they were well connected. So when we opened, by that very day, I could remember one of the resistor was 470 ohms. So assume because you indicated it should be reached from 70 to 100. So I don't know, maybe when you open, or maybe you have a resistance whereby you have higher readings that goes beyond 70 to 100. So what would you do? Or maybe could it be that that radon woman is faulty, or it depends on the brand that you are saying that? Thank you.
Okay. Thank you. I think that these days with different medical devices coming from everywhere, the first thing would be to maybe check with the manufacturer's recommendation. But this standard I'm using is from the IC standard for neonatal thermal devices. But as you said, there could be a possible devices that have come which ranges far beyond or below this particular one, which according to the manufacturer, it is okay. So as well as this particular, this standard is there to guide device manufacturing, I think manufacturers sometimes are able to use their own different standard, which does not conform with the IEC standard. So I can't say that it is wrong or it is correct unless you confirm with the manufacturer to be sure that what you are getting is actually what was kept in the machine. Thank you.
Thank you very much.
Yeah.
What a great presentation. What a great dialogue after. This has been excellent. Thank you all so much. Raymond, thank you so much for this really impactful and high value presentation. It was a very well done talk. If there aren't any more questions, again, round of applause, everybody, for Raymond. We will be posting this video within the next few weeks on our YouTube channel, and you can share it with your colleagues. They weren't here today. And we'll also have that link up from our website, ghanamedicalhelp.com. Please, everyone, make sure you subscribe to our YouTube channel so that you can easily get access to all of these videos in the future. And Raymond, if you're able to have more photos like the one at the end of your presentation you added in, I can use them on a Medical Help's project reports for our engineering project. So if you have any other photos like that, if you send them to me through WhatsApp or on an email, that would be really helpful to help with fundraising for the project. So.
All right. No problem. I'll do that. I have some more pictures.
Perfect. I love photos. You can never send me too many photos or videos. That really helps me help fundraise for the project and give project reports. So thank you. And Dominic, Dr. Akatiba there posted our YouTube video in our YouTube link in the chat. So if you click on that link, it'll bring you right to it. Is there any other bits of feedback, comments, anything that we wanted to talk about today? Anything else? Thank you, Dom. There's the link to the Facebook page, LinkedIn page, and YouTube. It would be great if everyone hears.
I'm sure I can stop sharing.
Sure, but it's such a photo.
Thank you. Thank you.
Thank you.
I'll send them.
Thank you. Okay. Okay, then we'll adjourn. I hope everyone has a wonderful end to your weekend. Thank you so much for your time. We'll meet again next week for our project team meeting, and I'll talk to y'all soon. Stay healthy and well.
It'll be in 2 weeks.
2 weeks,
it?
thank you.
2 weeks.
I have it on the 19th for the project team meeting, but oh, sorry, different meeting. Yes, 2 weeks for our next engineering meeting.
Yep.
Thank you. All right.
Great. Yep, great discussion. Fabulous. Have a good week, everyone.
Thank you.
Thanks.
Enjoy your holiday. Enjoy your holiday tomorrow.
Okay, thank you.
Happy holidays, guys. Bye.
Bye.